Welcome back to Golang for Devs. Today I'm covering all things structs, which are the Go equivalent of classes with some nuance. Let's get into it. Okay, you can define a struct type using the type syntax. And then you define the fields and their types in the struct. Note that any field starting with a capital letter is a public or exported field, while anything starting with a lowercase letter is a private or unexported field. The only difference is that a private field can't be accessed from outside of this package, but anything in this package can access that field. Okay, up next is actually using the person type. So you can create an instance of a struct using literal syntax like this, where you provide the values for each of the fields in the struct. Then shorthand syntax also works. And you can initialize a struct as a pointer using an inline ampersand like that. If you want, you can also rely on the ordering of the fields in the struct. So instead of explicitly listing name as a field, you can just provide the actual values. Though I'm not a huge fan of this because it's less explicit and harder to read. You also don't need to provide a value for every field in the struct. So if I just provide the name, the age gets instantiated as the 0 value for its type, which is 0. And lastly, the 0 value for a struct is an instantiated struct with all of the fields set to the 0 value for each of the field types. So in this case, name would be an empty string and age would be 0. So for structs, the 0 value gives you the same result as instantiating an empty struct, which is different from maps or slices, which have a 0 value of nil that's distinct from an empty map or slice. So the important point here is that struct values can never be nil. So there's no way to check if a struct value is instantiated. But you can get around this limitation using a pointer to a struct, which can be nil. Okay, accessing and modifying structs in Go is super simple. So if I have a person instance, you can access the fields of the instance using very simple dot notation. And in the same way, you can modify a field using dot notation. It's also important to know that structs are value types, not reference types. So when you pass a struct into a function, a copy of the struct is made. But one nuance with structs compared to other value types is that when the copy is made, it's a shallow copy. So any fields that are a reference type in the struct only have their reference data copied, not the actual underlying data. This also applies when making your own copy of a struct. So let's say I have a hypothetical struct type with a field that's a slice. A slice is a reference type, so when you make a copy of the struct, only the slice header is copied. So both slices will point to the same underlying array. So if I mutate the slice in the copy struct, the same change will be applied to the original struct as well. And if you think that's annoying and confusing, you're 100% right, and you should definitely subscribe for more videos showcasing the fun stuff you'll have to deal with as a developer. Now you might be wondering how to add methods to a struct in Go, because an object with no methods is pretty useless. It works differently in Go than a lot of other languages, and you don't define the method directly in the struct body. Instead, you have to attach it to the struct after you declare the type. So to do that, you declare a function, and then before the function name, you put the instance name and the type. So this type will link this function as a method to the person struct. Then you just finish your method as normal. And you can access the struct instance using the instance name that you put in the function definition. And it's super easy to call the method. If I have an instance of the struct type, you just use regular old dot notation, like literally every other language. So if I print this, it will come out as 21 because you've added 1 to age using the birthday method. Now, there are 2 types of methods in Go: pointer receivers and value receivers. The birthday method up here is a pointer receiver, which means when you call the method has access to a pointer to the actual instance value. You can make it a value receiver by removing the star in front of the person type. Now the method will get access to an actual person instance and not a pointer to an instance. But since structs are value types, the instance passed into the method is a copy of the original instance calling the method. So this method now adds 1 to the age of the copy, not the original. So if we go back down to where we called the method, this print will now print 20 instead of the expected 21 because we're altering a copy and not the actual instance. So when should you use a pointer receiver and when should you use a value receiver? First, if the method needs to mutate any fields on the struct, then it needs to be a pointer receiver. Otherwise, you're modifying the copy. Then if you have a very large struct, you should use a pointer receiver as well because you're preventing a large copy of the struct from being created. And lastly, if there are any fields in the struct that must not be copied, you should use pointer receivers. Then I would only use value receivers if you're making an immutable type or you need value semantics when you are calling your methods, meaning that the struct instance is always copied when you call a method. An example of this is the time.time type from the Go standard library. In general, it's better to default to pointer receivers instead of value receivers unless you have a specific reason you need to use a value receiver. And it's also convention to only use one type of receiver for a single struct type. So if I have a pointer receiver, then all of my methods should be a pointer receiver. This isn't always possible, but it's a good thing to strive for. Okay, unlike classes in other languages, Go doesn't have inheritance for their structs. Instead, they have something called composition. So let's say I have a building type with a couple fields and one method attached to it. But I need a specific house type. Now, instead of repeating the fields and the method from the building type, you can embed the building type into the house type and then add whatever other fields or methods you need. So this line here promotes all the fields and methods from the building type into the house type. So you can access those fields and method from any house instance. One nuance is that the promoted fields are not available when you instantiate a struct. So if I want a house with the fields from the building type populated, you can't just do it directly. Instead, you need to set the actual embedded field as its own struct. But once the struct is initialized, you can modify and access the fields normally. And you can also call methods from the building type as you would normally. There are some more gotchas with composition when you're using interfaces, and I'll cover that in the next video. So subscribe and stay tuned. Okay, the last feature of structs I want to cover in this video is Struct Tags, which is one of the more interesting features in Go. They're basically special annotation strings that you can add to fields in a struct to change runtime behavior using reflection. As an example, the encodings/JSON package in the standard library uses Struct Tags to automatically handle JSON encoding and decoding. So if I have a regular struct type with an ID field, I can use a tag to tell the JSON package what the corresponding key is in the encoded JSON. So if you were decoding from JSON, the package would expect to see a user ID key that it would map into the ID field on your user struct. Another common one used with the JSON package is a validate key. Note that the fields you use tags on need to start with a capital letter and be exported for the packages to work with them. There are a ton of different tag sets that you can use with the Go standard library and other third-party packages, and I'll leave a link to an index of those in the description. And that is everything you need to know about structs. There is a bunch more stuff you can do when interfaces get involved, so stay tuned for my next video. And if you want to see any of the code or diagrams from this video, I'll leave a link in the description. As always, keep breathing, keep building, and I'll see you next time. Peace out.